Dijkstra's algorithm is a shortest path algorithm in a weighted graph from a source vertex to every other vertex. An example could be finding the shortest distance in a road network. For each vertex, find the unvisited vertex V where the distance is minimum. For each unvisited vertex R that is adjacent to V, check the following condition. If the distance from the source to R is greater than the distance from source to V plus the edge from V to R, then update the distance to R to equal distance to V plus the edge from V to R. Let's look at an example. Suppose we have the following weighted graph, with 1 being the source vertex. We want to find the shortest path from the source vertex to every other vertex. For this algorithm, we will store important information in the table on the right. The distance column represents the current best-known distance from the source vertex. The visited column represents vertices that we still have to check. The path column represents the current best-known path from the source vertex. Next, we find the vertex with the shortest distance that is not already visited. In this case, vertex 1. Let's update the adjacent vertices. The distance for 2 becomes 20. The distance for 4 becomes 14. And the distance for 5 becomes 30. Vertex 1 has no other adjacent vertices, so we are finished and can set it to true. Next, we find the vertex with the shortest distance that is not already visited, in this case, vertex 4. The new distance to 2 is the distance to 4 plus the weight from edge 4 to 2, which is 26. This is greater than the current distance 20, so we do not update. The new distance for 3 is 31. This is less than the current distance, infinity, so we do update it. Vertex 4 has no other adjacent vertices, so we are finished and can set it to true. The next unvisited vertex with the shortest distance is 2. The new distance to 3 becomes 24. This is less than 31, so we update. The new distance to 5 becomes 25. This is less than the current distance 30, so we update it. We are finished with vertex 2, so we can set it to true. The next shortest distance is vertex 3. Vertex 3 only connects to vertex 1, which is visited, so there is nothing to update, and we can set it to true. The only vertex left is 5. Vertex 5 doesn't connect to anything, so we can skip it and set it to true. Now that each vertex is visited, the algorithm is complete. We now have the minimum distance from the source vertex to every other vertex, along with the path to get there. Thank you for watching. Please be sure to like, comment, and subscribe.